Welcome to Chapter 5, Section 2, Solving Inequalities by Multiplication and Division. So, Section 1 was all about addition and subtraction. And when we solve inequalities with addition and subtraction, we solve them the exact same way. So this one's going to introduce a new rule because it's inequalities with multiplication and division. So first, before we get into that, let's just introduce the screen like normal. So the first thing you will see on your screen is the due date. I don't see that on the teacher preview, but you will see it on your screen. You will also see the number of attempts here. So I'm on attempt number 1 of unlimited attempts. That means I can come in here and submit this assignment as many times as I would like. I'm not limited on that one. Number of questions just tells us how many questions are on this assignment. So there are 5 on this particular section. Just depends on the section and what was available there. There's going to be anywhere from 1 to 10 questions. Grading policies, best score, whichever attempt is the best one is the one you keep. And partial credit is enabled, meaning that if you do 1 of 5 questions, that you get credit for the 1 question. So please remember, always start once you start the homework, you must finish your homework before you can work on anything else. So that means once I click start here, on your screen, you will see down here below a submit assignment button. I don't see that on the teacher preview, but you will see it on your student screen. No matter what at this point, if you want to leave this screen, even if you haven't actually started, you need to click submit assignment. So even if you've only done 1 of 5 questions, make sure that you click that button for 2 big reasons. Number 1, puts it in the grade book and lets your teacher know what you're working on so that it's not just kind of locked out. Number 2, that locked out feature means that it's going to lock you out of everything. It's going to assume that you want to leave this attempt open and this is what you want to come back to. So it won't let you work on any other assignments until you click that submit assignment button. It saves your place. It's not going to make you start over or anything like that. So wherever you left off, if you've already answered questions and gotten a little green check mark for them, you're not going to have to do them again. It's going to start you back where you left off. So it's a very nice feature there. On the side, we have explanation, example, and message center. So explanation is going to tell you you're going to lose a question attempt because it's going to give you the solution to this question. So it's not going to, then let you come and type the answer in. So you'll have to come in on another attempt. Example gives you a general example, kind of a specific general example. So an example for this problem type shows you exactly what to do on it. Once you're happy with what to do on it, then you can close it. You can open another example if you would like. Message center just literally opens the message center so you can message your teacher and we know exactly where to come help you. All right, so we're talking about inequalities and you can see I already have some silly little drawings after the side here. So these were from the first section. We have less than and we have greater than. We also have less than or equal to or greater than or equal to. So if I hear equal to, it means I put a little line underneath them like this. Okay, so it's like half the equal sign under there. So those are also some options. And you can see I like my little Pac-Man figures for whatever reason. I don't do alligators, I do Pac-Mans. But this is just the idea of it's a quantity. It's bigger than a number or smaller than a number. So we kind of have a starting point and then a range of answers that will work within that starting point. It's not going to be a simple it equals this number anymore, not with inequalities. We will go back and forth with single solutions and inequalities. We're not going to just stay on inequalities for the rest of the semester. All right, so let's look at this one. When they give us a table of values, and they want us to determine which one is a solution. When we do this with an equal sign, only one of them could be a solution. Sometimes none of them are. I have seen it do all yes and all no on inequalities, or all no on an equal sign. But when we have an inequality, because it's a range of answers, we're going to have possibly more than one yes. So what we want to do is, number 1, we want to solve for this inequality. We need to know what is V greater than or less than. So we don't want to know what 2V is. I want to divide by 2 on both sides. So I get 9 is less than or equal to 2 divided by 2 cancels, and we have V. I'm very picky about the order. I said this a whole bunch on the last video, and I'm going to say it a bunch on this one. I always have it go variable inequality sign number, because when we start to graph that and we're reading it, it's much easier and makes a lot more sense if we have the variable on the left side. So V and 9, I'm flopping their spots. And then I need to make sure that this inequality sign kind of follows the same pattern. So it's pointing at the 9. It should also be pointing at the 9 when I flip it around. So it's kind of like a mirror image. I'm literally just flipping it around. So now, if I think of a number line, I can kind of picture this like a very basic number line. I have 9, so I'm just going to say 9 is over here. And this V is going to be greater than or equal to 9. So it's anything, it can be 9, it's equal to it, and it can be anything greater than that number. So, and we can see this is pointing in the same direction. If we look, this looks like a greater than sign. So that's kind of the whole purpose when I say graphing it, and think of the graph, we want it to be variable inequality sign number. It doesn't work if it's backwards. This is pointing in the wrong direction because we want it to be the variable first. So now we're just going to look at these numbers and say, do they work? So the first one is 9. Well, that's equal to 9, so that works. 6 would be, somewhere maybe right here. Well, that's not within the range. That's before it. 12, that would be somewhere maybe right here. And 11 would be right before that, like here. And I know that's not perfectly spaced, but it's the idea that it goes after 9 but before 12. So 9, 11, and 12 do work for the solution, but 6 does not. So we just click no for 6. All right. So, let me see. I'll erase this guy because we don't need this. So now it says solve for the inequality. Solve the inequality for y. So just like we would any other solution, we're going to solve for this guy. So we're going to use opposite operations to get that variable all by itself. So I'm multiplying by 4, right? I'm going to divide both sides by 4. Boop, 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 just like that. So now I have 4 divided by 4 is 1, so y comes down by itself, and that's greater than or equal to 20 divided by 4 is 5. So we have variable, and then we have inequality sign. Make sure you're choosing the correct one, because if you don't choose the correct inequality sign, this answer won't be correct. So definitely make sure you're paying attention to which one you're clicking on here. So we are going to start to get into negative numbers, I believe, because that's where we start to get a little different. Perfect. Here's one. So we have negative 4x is greater than 16, and this wants us to solve for x. So this is the only thing that's really different about solving an inequality as opposed to an equality. So when we have an equal sign, multiplying and dividing by a negative number doesn't really change anything other than, it might change the sign of the other side. It still does that same task, but what it also does is it flips the inequality sign. So we have negative 4 is being multiplied by x. So just like this 4 over here, I'm going to divide by negative 4 on both sides because I want to move it from the left to the right. I want to get x all by itself. Negative 4 divided by negative 4 cancels into 1, just like it did over here, 4 divided by 4. And then 16 divided by negative 4 is negative 4, because I'm doing a positive divided by a negative. The other thing I need to make sure is I divided by a negative sign, or a negative number, and if I multiplied by a negative number, it'd be the same thing. This inequality sign is going to flip around. So that's the huge difference there. We have to remember that if we multiply or divide by a negative number, flip the inequality sign along with that, the sign of the other number. So it's not a huge, it's not terribly difficult to do. It's just something we have to remember is done. It flips it. And we can think of it when we're doing negative numbers, when we're multiplying or dividing by those, we're thinking of it's the opposite of. So the opposite of greater than 16 divided by 4 is less than negative 4. So we're just doing the opposite of. It's just kind of a simplified way of thinking of it. That's why we flip it around. All right, so we're going to do this next one with some fractions here. We seem to like to do some fraction practice on some of these. Remember, a fraction it's literally multiplication and division happening at the same time. The top is multiplication, the bottom is division. So if I want to undo multiplication, I divide. If I want to undo division, I multiply. So when we have a fraction being multiplied by a number, we do the same thing, we just do it at the same time. So I'm going to multiply by 7, and I'm going to divide by -4. So it's called the reciprocal. We just flip it over, and we multiply both sides by the reciprocal, because I'm multiplying. 7 divided by 7 cancels, -4 divided by -4 cancels. So that's why we flip it over. And we do this to both sides. So these guys canceled out to 1. 7 divided by 7 is 1. -4 divided by -4 is 1. U drops down. And then on this one, I'm going to multiply across the top. So I have, 70. And then there's a 1 under here. Even though we don't see it, it's there. All numbers have a 1 under them, because anything divided by 1 doesn't change it. It's an identity. Multiplying or dividing by 1 doesn't change the number. So I can have -4. And then the only thing I need to do is reduce this. It's going to want it simplified as much as possible. So I'm going to divide both sides here by 2. And I'd have 35 over -2. So 35 over -2. And I believe it's going to let me leave this a fraction. It does have a mixed number here, so we'll see if it makes me do that. Kind of depends again on the problem and where we are in the semester, whether it makes us do that. But remember, I multiplied by a negative number. Even though it's a fraction, I'm still multiplying by a negative number. So this is going to flip around. It's not going to be greater than or equal to. It's going to be less than or equal to. So U is less than or equal to -35 over 2. And if you notice, that negative, instead of it being on the bottom with the 2, I put it in the front here. It will accept it on the bottom if it does let you do that. But it's going to give you grief about it, because the proper way to write it is kind of in the middle here. Because the negative can go to the 35, the negative can go to the 2. It really doesn't matter where the negative goes. Depends on what you're applying it to, but this matters a little bit more when we're doing like slope or something like that, where the negative is when we have a fraction. But in this case, we tend to put it in the center there. All right, so perfect. It had me do that. I believe, and I'd have to go and try another one, but I believe it would also let me type in a decimal here. It would probably let me put in the mixed number, seeing as that it gives me that option. So this one would accept quite a few different answers here. All right, I think I need some more room. I'm running out of room here for my last problem, and we get another word problem. So word problems kind of connect us back to, here's a story behind it. Instead of just giving you some numbers, here's actually a scenario that would work with these types of numbers. This is where we would use it in real life. So Amy runs each lap in 8 minutes. She will run less than 72 minutes today. Not miles, that's a lot of miles. So less than 72 minutes today. What are the possible numbers of laps she will run today? Use n for the number of laps she will run, and they want us to solve the inequality for n. So they actually want us to go all the way to the end, not just write an inequality, but solve it. So let's think about it. Again, it doesn't really matter who it is. In this case, if it just said laps in 8 minutes, that might not make a lot of sense if we didn't know we were running 8 laps. Or it could be swimming, could be biking. Really doesn't matter what the activity is, but we probably need to know kind of what's going on just to picture that in our heads, a little better. But so this person, Miss Amy, she's running laps, and she does that in 8 minutes. So each lap, and I'm just going to write 8 minutes, and I should have put that first, but that's okay. 8 minutes for each lap. And she's going to run less than 72 minutes today. So it's less than. It just says less than, so I know I'm going to use a less than symbol, and it's 72 minutes today. So now it asked us to use n for the number of laps. So each is a multiplication word, and n for laps. So I'm going to go 8n. I don't need to put the dot here anymore. And I don't need to include the word minutes. I didn't put minutes on this side either. I definitely wouldn't include that when you're writing the inequality, because it tends to look a little bit confusing. So we have 8 minutes per lap, and that's going to be less than 72 minutes. So let's go ahead and solve this. It's being multiplied by 8. I'm going to divide by 8 on both sides. 8 divided by 8 cancels, and n is going to be less than 9, because 72 divided by 8 is 9. So n is less than 9. Check. All right, so that was section 2. I will see you in section 3.